Hi, in these tutorials we are going to explain and make car detection project. In this project we will classify cars and detect them in images and videos. I divided the project into 5 sessions. The first and the second one we are going to explain important concepts in the project, and we will set up environment and install libraries that we will use in the project. The last 3 sessions we will be going through the implementation of the project, and we will write the code together. We will use machine learning to perform our task. I hope these tutorials will be useful for anyone interested in detection of objects, and especially in car detection. So hi again. We will talk here about some basics and fundamental informations that will help us to understand the project and the idea or the science behind it. And this session and the next one will help us to understand the code that will be discussed later. Okay, let's begin. So the most important question, what you will learn. So firstly, what is machine learning? Machine learning is new field or science that have a lot of applications, so we will discuss this briefly in the next slides. Secondly, how to make classification via machine learning. Classification is one of the applications of machine learning, so we will learn the steps or the procedure that we will do to make classification in our project. Next, how to use Anaconda and set up different libraries. Okay, Anaconda is a program that will help us to run our project. We will move step by step. On how to set up it and install different libraries, as our project need a lot of libraries. So as I said, we will go through how to set up these libraries step by step together. Okay, how to extract features from images. So extracting features from images is very important, and it affects our model and affects the training phase, as when I train my model it depends on the feature. So if I extract wrong features, my model wouldn't make the task I need. So I have to extract the right features that will give me the maximum efficiency I need. So if we think about this, we have to know that extracting features and training our model are equally important. So we have be careful when we extract features from images, and this is very important. Next, we will learn how to evaluate our model performance. So when we think about model performance and how to evaluate it, it is very important to know if I move on to my target, what I want, or I have got away from it. And we will discuss how to make this, how to use a sliding window. Sliding windows help me to know where is the classified object is in the image. We will discuss this soon. Detection of cars in images and videos. It might seem that they are the same, but actually it is not The main issue is that our model can be work on the images very well, but when I try to use it on videos, when I see videos, it's really equal to real-time world. So the model can be very slow or doesn't work as well as I predicted it. So it is very important, and we have to be carefully when we detect our car in images and we use this model that we have been created to use it in on the videos, because real-time world is a little bit different on the images. As the images, it may be static, but the real world is dynamic, so it will be different a little bit. So let's move on. Okay, application of car detection. Okay, our project have a lot of applications. We will discuss 3 of them. Radars are one of these applications. If we detect cars in real-time world or real-time application, by doing some mathematics, we can get the speed of this detected car. So that radars is one of these applications we can use. Braking assistance. If I drive my car and there is a car where collides me, braking assistance will use car detection to know the distance and will apply the brakes in the suitable time. The last thing is self-driving cars. You will never see a self-driving car that doesn't have a car detection program. It is essential that it have car detection. Okay, as I said, these are 3 of the applications that might found for car detection, and of course there are others. Okay, machine learning. What is machine learning? As we see here, machine learning is divided into 2 branches: supervised and unsupervised learning. Supervised learning is that I have labeled data set and I trained it, and supervised learning is divided into classification and regression. Classification will be discussed in more details in the next slides. So regression. When I say regression, it means prediction. If I have any application that need to predict things, I use regression. Unsupervised learning, we use it when we have the unlabeled data. So we use unsupervised learning techniques like clustering to train it, and it will classify and label this data. For example, if I have data of the sales of a company that sell mobile phones, the classifier here will train this data, can classify it according to the people who buys these phones, how old are they, teenagers or old men, and what they bought, and how much each of them spent. So clustering is used in complex applications, and it has its own implementation so that it can divide things into categories, different categories. So this is the most important things that we have to know about machine learning. Okay, next. Classification. Classification is one of the machine learning applications, and actually it is the most important one, as classification allow me to classify between things. For example, dog breed classification via machine learning. I can classify between different types of dog. So by using it I can classify between different types of dogs, not only to classify if it is a dog or not, but also classify between different species and different breeds. Even they are similar species and the human can't classify. The classifier will classify between them with high accuracy. The second example is personalized medical diagnosis. If I have data of a patient, I can use this data and train it to find if this person have a certain disease or not. So here I can find if the person or the patient have this kind of disease or not, without need of a doctor, which is very interesting. There is multiple application and a lot of application on this field, and actually it gives me high accuracy, which is very useful if we think about that in the future there will be machine learning can work as a doctor or can make applications that doctors do. It is very complicated, but it is in the real world. Okay. Classification algorithms. In the previous slide I said classifier. So what is meant by classifier? Classifier is the method or the technique I use to train my data. There are different types of classifiers in machine learning. For example, I can use classifier in classification, but I can't use the same one for regression. It is totally different. So here in classification I have different classifiers. Each one has its own implementation and use. For example, linear classifier is fast, but its accuracy might be low in complex data. SVM is good to use if data is small, but if the data is huge, it is preferable to use decision trees or AdaBoost classifier. Each algorithm has its own use and its own application. So you have to take care when you choose your classifier or algorithm for a current application. In our classification algorithm. So let's move on. Support vector machine. So what is support vector machines? Support vector machines, SVM, are one of the most important classifiers in machine learning. It comes from supervised learning and has both application in classification and regression. But here we talk about classification. So here we plot two. So when we look here, we have plotted two different classes of anything. The red dots are the first class, and the blue dots are the second class. So can you predict which line of the three lines will be our SVM line, or will separate the two classes? Okay, the middle line will separate the two classes with maximum efficiency. But why? The two other lines also separate the two classes from each other. This will return as the same point on the C that. So I'm sorry. So this will return us to the same point on how SVM works. Okay. So SVM is work by margin. Margin is the distance between the line and the classes, or nearest points in each class. The line with the maximum margin will be our line, or the line of the support vector machines. The line with the highest margin will be the best line to separate the two classes. Here is another example. Can you predict which line will separate the two classes? Okay, right. This line is the best one. This one on the left. Not only it has the highest margin, but also this line separates the two classes totally from each other, while the other line misclassified the two classes. Let's move on. Support vector machines outliers. Let's take a look of this example. Here I have two different classes. The problem here, there is blue dot in the red dot classes, which we call outliers. So if I apply support vector machines, the model will be very bad and will misclassify a lot of data because of this blue dot, which we call outlier. So how we can solve this problem that will harry our model or will destroy our model? Simply, we can solve this problem by remove this outlier. So if I remove this blue dot from the red dots classes, the problem will be solved, and my model will be smooth, simple, and will totally separate the two classes. So before training our model, we have to remove outliers. It also depends on application, but in the most situations, it's better to remove outliers. Okay. Nonlinear SVM. Here, if you think on how we can separate these two classes, if we think if we think about straight lines, it is actually impossible to do that with simple line. So here linear SVM fails to solve this problem. So what shall we do? So the most reasonable and efficient solution is to draw a circle between the two classes. So there are cases that we will need to use non-linear SVM to solve our problem. We can draw circle, we can draw rectangle, any shape that is non-linear. Here is another example, as our two classes are drawn or plotted, but not in 2D space. Here it plotted on 3D. I have 3D data. So the only thing that can separate these classes is to draw plane. So this green, it is the plan that separate the two classes. So this green plane separate the two classes. There are a lot of situations we have to consider before we train our model or choose our model to make our classification right. We have considered a lot of issues in our mind. So let's move on. Okay, so support vector machines overfitting. What is overfitting? Overfitting is a problem that appears when we train our model on the training set too much, so that it will perform well in the training set and give me high accuracy. But when I try it on any other data doesn't included in the training set, the model will fail to classify it right. So here we see the same data we trained it on 3 different models. Okay, we see the same data we trained it on 3 different models. So in the left the model is simple and different and direct, but it misclassifies and doesn't separate the two classes very well. The second model is not linear, but it is smooth and give me generalization, and it separated the two classes with maximum efficiency. The last model, it separates the two classes very well, but it isn't smooth and not generalized as the second model does. So the third one, it is not smooth and not generalized as the second model does. So we call the last model, it separates the two classes very well, but it is not smooth and not generalized as the second model does. So we call this model is overfitting. So you have to consider how your model generalized the data and not only look on how it separated the two classes from each other. So overfitting is important thing that we have to take care when we make our model. Okay, this is the end of this session. We will continue in the next one. We will continue from what we have finished from the last session. Then we will talk about how to set up and install the libraries and the environment that we will be used in our project. So let's begin. Data processing, or how to process data. When we talking about data, we have to consider about the shape and the type of this data, because this will affect our training model. If the data is very big, it can take weeks or even months to be trained. Data can have outliers or wrong type, which will make our classifier have low accuracy. So first we have to check that the data is right and there is nothing not normal. If we have data vary in size, we have to normalize it. For example, images contain pixels. Each pixel vary from 0 to 255. So when we normalize it, it will be better for our model. It is preferable to normalize it. If there are outliers, we have to remove them. This is very simple procedure to process data. Okay, color histogram. So we will talk here about how to extract features from images and feed them to machine learning classifiers. It is a little bit hard to extract features from images and use it in machine learning, but we will walk through each step and explain these steps. Okay, firstly, color histogram. First we will talk about color histogram. A color histogram is the distribution of the colors in an image. In our case, we want to detect the object, so it is the distribution of an object in an image. So if we want to detect a car in an image, we will make a histogram of it and compare it to the whole image or each object in the image. There is a problem that can be hard to make this. When an object which is not a car will have the same color histogram of the car, the classifier will think it is a car, so the accuracy of the color histogram is limited. So we will use it as a feature. So what I will say is that the color histogram is limited by the accuracy. It will not give me the accuracy I need. It depends on the image and on the object I detect, but we don't have to think about it as it will be feature from other features we use. So color histogram, here I draw a color histogram. I have X and Y axis and I draw a color histogram. I divide them into pins. So for this example here, the image or the object have these colors. I have a lot of orange, then red, and the other colors. Okay, here is another example. You can see here color space. Here we will talk about color space. Any colored image consists of different types of layers. For example, RGB image consists of red layer, green layer, and blue layer. So in color space, we draw each layer in the 3D space axes X, Y, Z. For example, red in X axis, blue in Y axis, green in Z axis. By doing this, we get new presentation and new features that will help us to detect the object we want to detect. There are different types of colored images. You can see here there is RGB. Yes, there is other types. Here is HSV. HSV image. There is 3 layers. Hue layer is the color portion of the color model and is expressed as a number from 0 to 360 degrees. For example, blue color is from 240 to 300, as expressed in this circle. Saturation, as we said, HSV, hue saturation value. Saturation is the amount of gray in the color, range from 0 to 100%. Value is describes the brightness of the color, so it's from 0 to 100% also. There are other types that we can use in the color space. Gradient feature. Okay, here is the gradient feature. Image gradient is a directional change in the intensity or color in an image. The gradient of the image is one of the fundamental building blocks in image processing. So here we have image, we divide it into different grid cells. Each grid cell will have a symbol. When we collect those symbols together, we get a signature for this image or this object in the image. So as we see here, I divided I divided my image into different cells. Each of these cells have its own orientation or symbol that describes this port. Okay, Hogg features. The histogram of oriented gradient Hogg is a feature descriptor used in computer vision and image processing for the purpose of object detection. We can think of Hogg features as we take a group of grid cells, and we can think of Hogg feature as we take gradient feature of this image and then divided it into different grid cells of the gradient image into groups and see the most repeated symbol in each group, and take these symbols and put them together, so this gives us a signature of this image. For example, here I have divided these images into different grid cells as here. So after I divided it, I take group of grid cells. Say I have take this group, I have take this group, this big rectangle, I have took it. Then I calculate the most repeated symbol in this group. Then I put a symbol or a signature for this group, so that the whole image is divided into, say, it is object in any image. So it is a very efficient way to detect the object is to use hook features. Why we use hook features, not the image gradient? The image, because hook features give us a very good representation and description of the image or the object we want to detect in the image. In our case, the object we want, and doesn't take a lot of memory like image gradient with high accuracy. So when we train our model, it will doesn't take a lot of memory. The last thing I want to talk about is sliding window. Yes, here is another example of hook feature. So here I divided the image. So this is the image gradient. It contains a lot of symbols. In the last image, C is the hook feature. So I have grouped this, divided this into groups, and C the most repeated sample in each group, and I defined my image as it. Sliding window. So when we perform classification and our model classifies well, the problem is if I have a classifier that classify object, anything, cat, dog, anything. If this object is in image, the classifier will classify it, but wouldn't tell me where this object appear in this image. There is a lot of applications that I need to classify object and know their place or their position in the image. So I have to use sliding window that I have divided. I have to use sliding window. We can think of a sliding window that I have divided my image into multiple images, and I use my classifier to classify each of them individually, so that if it classifies the target object, I will know its position in the image. So I think we have finished this part. We will now go through how to install and set up different libraries that we will use in our project. Okay, we can see here. Okay, the first thing I want to make, okay, we will begin by installing and download Python. In this project we will need Python 3.6. Okay, so as we see here, Python. Okay, okay, we can download Python from here. 3.7, 3.6. I prefer 3.6. We will find it here. So after downloading Python, we need Anaconda. So Anaconda. Okay, Anaconda. Download Anaconda. Okay, we will need to install Anaconda 3.6. Okay, use Windows, so we can use Linux or Mac OS. Okay, we will download the Python 3.6 according to your system, 46-bit or 64-bit or 32-bit. Okay, after that we want to download. In Python and Anaconda, use the default setting to install it. We'll download the dataset we will use, vehicle image database. It is a link here. We'll download the dataset from here. Feel free to use any other dataset you have. So feel free to use any dataset you have or you want to use. There is another site that contains a lot of dataset called ImageNet. I have right car in the search, so I have a lot of datasets that I can use in my model. Feel free to try any of them. Okay, after I installed Anaconda, I will install the libraries I will need. So here you write Anaconda from it, so you will get Anaconda here. So now we will install our dataset. The dataset here contain of vehicles and non-vehicles. This is examples of the non-vehicles images I will use. Each photo, all the photos have the same size. You have to be sure of this. Okay, and the photo list is 32 by 32, I think. Properties. You have to be sure that they have all the same size. Okay, the dimension is 64 by 64. Okay, and the vehicles. Okay, this is my dataset. Okay, they have the same size of the non-vehicles, 64 by 64. Okay, the requirements. Those are the libraries that we will use in our project. So we will begin to download them. It is a very simple process that we will do. Okay, write Google. For each of them I will write the conda install. So if I want to install Matplotlib, write conda install block. Okay, there will be a link here that will help me to install it. The internet connection is a little bit slow. Okay, okay. So we will copy this. Okay, so Anaconda will install this package for us. We can use Matplotlib. Okay, can install it. Install Matplotlib using conda. Okay, Matplotlib. So it will solve in environment. After that we will install it. Now this will take the first one. After this finish, I will install Matplotlib, and for each of these libraries we will do the same until we have finished all of them. So we have OpenCV, NumPy, skimage, sklearn, Pickle, Jupyter, Movie Boy. We will use all of them, so you have to be sure that you installed all these libraries. For now, I want to talk about the project and what we will do. So I divided the code into 3 sessions. The first session, we will begin to navigate to our directory and load the data that we will use. Then we will make the functions that we will use in the next 3 sessions mainly. Then in the next session, the second one, we will train our model and write a classifier, and the last one, the third session, we will use this classifier to detect codes in the images and in the videos. Okay, you can see now what happened here. Okay, solving environment done. This means that it found the package. So Anaconda here found the package of the library I globed. So I will pause the video until it finishes. Okay, as we see, the package has been installed. So here I will begin to install Matplotlib. So for all libraries, we will do the same until we finish them. If you found anything that not installed, feel free to write the name of the library, install the library you want using Conda and Google, and you will find direct link to the sentence that you will write in Anaconda here. Okay, this project is based on a self-driving car project called Vehicle Detection from Udacity. So okay, solving environment done. It will install now the Matplotlib. Okay, this is all for this session. Okay, Y is stand for yes, N stand for no. So you write yes. It will begin to install it. Okay, think we will continue in the next session. I hope it will be more interesting than as we will begin to start our project. Okay, this will be the first session that we will talk about, or we will start coding our project. So let's begin our journey. Firstly, I will import the libraries I have installed in the previous session. First, we will import OS. Okay, and import glob. Actually, glob is libraries that help me to loop over the images. Then import Matplotlib image as okay. Matplotlib is a library that help me to plot the images and graphs if I need to make any one of them. NumPy will help me to convert and extract features from the images and make the features ready to be trained in our model from image dot feature import hook. So as I said before, and as we discussed in previous sessions, hook features is from the most important things we need to do to classify images and objects. So we will use this library sk image dot feature to extract hook features. Okay. From sklearn import linear svc. Okay, this will be my classifier or the library of my classifier. Okay, pre-processing, import from pre-processing, import standard scalar, from pre-processing import standard scalar. This will help me to pre-processing my data. Okay, we will see this later. Import pickle from scipy dot nd image dot measurements import label. Okay, so far so good. Okay, if you want to check that this library is installed or not, so we will make quick test to check that. Let's save my model and I will open my Anaconda and I will navigate to my directory. I've already done this. Okay, let's Python vehicle. Python vehicle detection.py. This is the name of my file. We'll run it. Okay, this is error. I will check it from sklearn. Okay. Sklearn dot okay. Another error from sklearn dot pre-processing. Okay, we will find it. Okay, I found it. I hope it works now. Okay, so far so good. I have tested all the libraries is installed. Okay, we have imported our libraries, so we will now begin to load our data as we mentioned before. So I will call my directory vehicles. So I will put here my directory. So whatever you called your directory, use the name you have named your data. Image underscore type call list directory. Okay, here I will begin to loop over the vehicle directory that we have downloaded in the last session. Okay, of course we made a list. Of course we'll amend it with the directory type okay, we will loop through the directory, and so here it is globe. This globe library helped me to loop over the images which I need to classify my type. Okay, so here I will loop over my directory of which contains the dataset of the vehicles, and I will save this on the car list. Is open. It's open. Course list. Okay. Let's see. In course right. Okay, here as I said I will go over my directory and save the directory in the cores list. So I will make this, I will copy this and paste, as I will want to make this for the non-vehicles directory. So I will change this non-vehicles. Okay, none, not cars. Okay, not cars. Okay, so here I will loop. So here I will loop over the directories of vehicles and non-vehicles, and I will save each of them the name of the images and in the directories in these two lists, cores and not cores. So we can check. We want to print now to print the number of images found in vehicles, and or the number of cores and not cores to see them. So we have to. So we will print it. Print the numbers of cores in cores. Okay, then it calculates the array and return a number, which is the sum of the list in cores. We will do the same. We'll do the same thing for the cores. Okay. There is error here. We have to not cores. Okay. Check it on Anaconda to be sure that our code is right. Okay, so far so good. The number of cores here I print not, so it is only a word I have printed. So 8792. They have the same number. You might find that not cores have a lot of images. Actually 8800. So you can delete some images, so that we need the both lists to have equal images, as when we train our model, it found they have the same images, so there is not so we want the dataset to be balanced, so the number of cores and not cores have to be equal. So let's move to next. Okay, here we will begin to write functions that will help us to complete our project. I will write some of them, and I will copy others to save time. Okay. Okay. I have already put these libraries. So the first function we will use is called getHook features. This function help me to extract hook features, so that I can extract the hook features. So first it takes the image, the orient, we will define it pixels per cell. As we said before, we divide the images into different cells. So pixels per cell is a parameter that we will use. How many pixels do you want in the cell? cell per block, VIS and HRVEC. Okay, this function hog is already defined in the library of skimage, so that it extracts the hog features. Okay, let's move to another function. So the other function will be pin spatial, as we said before. It is responsible for the histogram of each image. So this function takes two parameters, the image and its size. By default, I will make it 32 by 32. Okay. Pin spatial. So sessions that if my image is RGB or HSV, there is also 3 layers. So I will make each layer, extract the features from each layer. So define color 1 equal CV2 .3 size image that I have entered. Size do travel, it is a function in NumPy that tells me that returns 1D flatten array. Help me in the forming the features I want. So I will copy it and do the same for the other 2 layers. Color 3 1 2. Okay, what I will return is each stack, color 1, color 2, color 3. Okay, so each stack, it makes the features horizontally. It collects the features and combines them. So it will combine the features from color 1, color 2 and color 3 and combine them and make them horizontally one feature. Okay, let's move on. So here, according to the image and the size, will be pin spatial function will work. Here we will define another function called color histogram. So when I I talked about color histogram, I have the first thing I talked about it when I make a graph of histogram of colors. So this function will help me to make this histogram and turn it as a feature. So how we will, so first this function will take the image and the number of histogram, the number of pins. You know, as we all know, the histogram is divided into bins, so you will define the number of bins. By default it is equal 32. Why I make things by default? As if the user forgot or to enter number of bins, it will be by default equal 32. I have the channels, channel for each layer, channel 1 contrast equal MB histogram image. Okay, we will use this. Use these bins equal the bins you have entered when you call the function. Okay, I will repeat this 3 times. Okay, we'll change the name to differentiate between each layer. Okay, 1. When you write your code, you have to look, you can find any error. Okay, so far so good, everything working good. Okay, so I want to make them one feature, so I will use concatenate function. So this underscore features for all the channels. Channel 1, channel 2, the last one, channel 3. Okay, let's move on. I have to check. Okay, I have to change this to 2. 3. Okay, we'll return. So I will return these features after concatenating it. Okay, what else? So I will define now big functions that will be used when I want to extract features from a single image. So let's begin. So here's define single image features. Take many arguments, image, color space you want. Okay. By default it will be RGB. Use user forgot to enter color space spatial size. Okay, 32 by 32. Okay, what else? Distance underscore yes equal 32. Okay. 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 Pixels where cell equal 8. Okay. What else? Cell where block. We'll copy it to make it more fast. Hook channel. Which channel I want to use. By default this is equal to 0. So what else I have? What else I have? Special feed. Equal true. True. I have an error. I will fix it now. Little error. Okay. Okay, I will find all this. So color underscore space not equal RGB. So if the user didn't enter RGB and enter another color space that he won't use, and yes, RGB is not only the best choice you can choose, it's other choices that I think it is better. So if color space, I will do more options here. If color space equal HSV. Okay, so the user enter color space equal HSV. So I will convert the image from the RGB to HSV. As I consider the test images, all the images I use are RGB images, and by default all the images are RGB. So feature images CV2 dot color image CV2 color. Okay, I have to characterize this color GB to HSB. Okay, what else? HSV, as we said, hue saturation value. There is others. Color space was not HSV, was HLS. Hue saturation value, no, HL. Hue light saturation, as I remember. So if it is it, so picture image will be RGB to HSV, no, RGB to H. So whatever I want to, if I want to use any type of layers, I have first to convert it from the RGB4 to what I want. Okay, let's continue. There is another type that we will use actually here. This type that we will use is YCRC_B. So this is another type of color spaces. This type Y stands for Y stands for luma. It is the lightness of the image. CR stands for component, red component, and CB blue component. So it has its own color space. As we mentioned, there are different types, so it is one of these types. I have to change this to this. Okay, so far so good. Okay, we will return here. So else if the color space is RGB, so I will only make a copy of it, as I will want it to be still RGB image. So I will make features image equal NB. So NB.copy will copy my image that I have entered from the beginning. Here I will not change anything as I want the image to be still RGB image. What else? Spatial file underscore features. So okay, special features. So okay, image features, which we defined earlier. Image features dot append. All of us knows that append will move the spatial features to the image features. Page spatial feature underscore features. Can wait. Okay, I write it wrong. It's not a problem. Okay. So far, so good. What else? If histogram features, which is features stand for histogram features. Histogram features. Okay. Equal true. So if I use my function and I called histogram features to be true, so that I will use this, so that if the hist feature equal true, so that extract the hist features. Hist score features equal color score hist. Feature underscore image. Okay. And equal list underscore as okay. And after extract it, append it to my feature image underscore feature dot append list append list features. I will copy it. So if I make spelling, the function will go wrong. First thing is hook features. True. So if hook fit equal true, that I want the hook features. If hook channel okay, if hook channel equal all, so that I want to extract all the hook channel features. Features equal for channel in range features underscore image. I write the code so that you can follow me. Okay, so hook features so that I will loop through the feature image to extract all features of all the channels. Okay, we can copy it from features. Okay, copy it from here. Okay, dot append. Okay. And first thing we'll do, we'll concatenate it. Choose concatenate the features. So that to be, as I said, concatenate feature will combine all. If it is a list, we'll combine it to one feature as I need. And finally, we'll do as we as I did for the above features. I will append it to feature image and the whole channel I need. Or I will use hook. So here, when I want to, not all the channels, I want one channel, so I will use this hook channel. But if I will use all those channels, I will return here. Choose. Here will be not the whole channel, will be only channel. So the last thing that I will do will be features dot and hook features. Okay, I return everything to the image features, and finally it's a really hard function, and finally I will return the image feature, but as one feature, so that image features now contain a list of spatial, color histogram of hook features according to what I want. So I want to make this one features also. I will combine them using concatenate function. Okay, I did it. This I will change something. I will just change small things only, so that I will have features called features, and I will loop over the images. It will not be image, it will be images, or I can, it's not a problem, we can call it image, which is not the thing. And I will change for file in image. As I mentioned, there is multiple images. Image file underscore features call. So I will move this array a little bit right. Oh, no, it's wrong. So okay. So I want to loop over multiple images and extract the features of each image in the folder. So I'll make this empty list, and I will and okay, after I will read each image in the of my list or in my folders. File. Okay. What I need now is to slightly change some file features equal empty list, so that now I will not append image features, I will append file features and file features. Okay, I have to move this a little bit like right to be the same, to be in loop, so that I can loop over it. Finally, I will features will now use image features. Okay, features dot append okay, I will refresh. everything. So here, if I want to extract features from a folder that contain multiple images, I will use this function. Okay, this is the end of this tutorial or this session, I'm sorry, and we will continue in the next session. So in the next session we will train our model, go through sliding window code, and we will train our model and we will see its performance. Okay, let's do it. Okay, hi again. In the last session we have talked about start coding the project. So in this session we will continue what we stopped in the last time, or in the last session. So in the last session we defined our libraries, we unloaded our data, then we defined some functions to extract features from images. Here we will continue and we will train our model in this session. So firstly, I have added some functions. I have added these functions, these three functions. These functions are for the sliding window. So I will go through each function in detail, but it is not important to know how it works or to understand the code. You can think it as a black box. You enter an image and the sliding window is done, or the sliding window is created. So you don't have to think about how it is coded or how it should work, as it is not really important. So the first function here is slide window. Takes several parameters. First, the image we want to make slide window in it. Second, xstart underscore stop. This define my image has x-axis and y-axis. So here I defined where I want the sliding window to begin in the x-axis and to stop in the x-axis. For example, if the x-axis is divided from 0 to 600, and I make x start underscore stop 200 300, so it will sliding window will move from 200 to 300. It will not take the whole x-axis. For the y start underscore stop, the same, but in the y-axis. X and y underscore window, it is the size of the window that will be moved through the image. XY underscore overlap, it is really how much each window will move. For example, if I have an image and I finish the bottom of it, so I will move in the x-axis 0.5 and in the y-axis 0.5, and I will continue until I scan all the image. Okay, I have made some conditions. If the positions of x underscore stop or y start stop or x start stop doesn't defined by the user, I will define it by the shape of the image. X span, y span, it is as I said, it is x start stop minus x starts. It is the range that we want the sliding window to move in the x-axis. Y span, the range we want the sliding window to move in the y-axis. pixels per step, nx pixels per step. We calculate the number of pixels per step in x, y positions. X buffer, y buffer, x windows, y windows. Here we calculate the number of windows in x and y. Windows list is an empty list that initialize a list to append window position to. Okay, let's move a little bit down. Here we will loop through the windows and through, and we will add positions to windows list or window list. These positions are the positions of the window position to the list. Okay, this is the first function, draw boxes. Okay, here I have draw boxes. It is functions that visualize these boxes. So after I classify, I want to visualize so that I can see where the object I detected. So draw boxes make this mission to me. It will take the image and will take the boxes, and simply it will draw for B box. In B boxes, CV2 dot rectangle. This is function OpenCV that help me to draw rectangles. So it will simply draw rectangles. Okay, let's move on. Search window. Okay. Okay, search windows. This function will do. Okay, this function will merge between the sliding window and the classifier. I would not go through it because this it talk about classification. As we can see, prediction equal classifier dot predict. We will talk about this, how to classify and how to make classification. So search window is this function takes the image, takes the windows I have defined earlier, takes the classifier and takes the parameters I have defined, so that here I get the features, and here I loop through the windows, so the sliding window here begin to classify if there is a car or not car here in our project. Okay, let's move on. Okay, here I will begin to I will start training my model. So what shall I do first? The first thing you have to consider is to define the parameters that I will use for extracting features. As I said earlier, extracting features is as important as training the model. They are equally important. So I have to be careful when I train my model. So I will define my parameters. So first color space Here I will use the YC brush, which we defined in the last session. Orients, hog orients. I don't know, but I think we can think of the hog orientations. It is as how many shape you want the hogs to define your image. I think it is the meaning of it. Okay. Let's self. We defined it. Feel free to play with these numbers and these parameters as they are. This is the meaning of the machine learning, and the meaning that you change the parameters with better accuracy, with better model. So don't be be flexible. Don't be fixed to this number. Be more flexible. Cell bear block. Okay. Say 2. Hog channel. We'll define all. Okay, spatial size. Okay, time. Okay, spatial feed. Okay, spatial size. It takes 2 parameters to give me an error if I run it like that. Okay. I will define the histogram features. True, so that I want the histogram features and the hog features must be true. It has to be true. Although you can make it false if you don't want all features, and you can try and see how the model will work. Okay. Y start underscore stop. We'll define this, but it will not affect the training as the sliding window doesn't have any relation between it and the training our training model. So here I define the parameters. Now I will define the parameters that will make me train the model in underscore samples. This is the number of samples that we want. We will choose for the classification. So as I said earlier, you have to make the cores, the number of cores and not cores equal. So if you don't make that, so n samples will make this for you. We'll choose random samples using nv.random. Okay, cores, as we know. Okay, we will choose random numbers from the cores. Random places of the photos, so that we can train our model. test one underscore sample one equal array course random. Okay, I'll copy, take a copy, force, not course. So here I have chosen 8000 image from each class randomly, so that the two groups or the two classes, course and not course, have equally data, have equal number of data. Okay, let's move on. Course here I will begin to extract features. Keywords underscore extract underscore features test samples one colors. Okay, we have a lot of parameters: color, space, underscore space, equal color space signature. Okay, I will copy it from the function of extracting, or you can write it, so that we special size equal. Okay. Special size is strings. Forget to define it. The strings. Okay. So it is good that I didn't copy it from the above, so that I can find any error. Strings equal strings. Okay. Orientations. If you found any problem with the code, go to the source that will be provided to you. As that I move step by step, I can make anything wrong. So if there is any problem, go to the source. I go step by step to make you understand the code, but you can take it from the source and run it. Actually, it will be more easy. I know that writing is interesting, and but it is really hard. Okay, pixels per self equal pixels per self. What else? Okay. Hogan channel. So I have made everything equal to this parameters I defined. So I can remove this and make color space Y, C, R, C, D, hood channels A, all, but to okay, special feed. Feet equal true, and the hook feet lost parameters we have. Okay, so let me check if all things work. Okay, special size, okay, so far so good. I will copy it. This is for car features, so we'll make the same for not car features. We have to change the samples, or we will train the model on the same thing, on the two same classes. Okay. So here I will combine and stack the features together, of course. VStack, in the last session we use HStack. HStack stands for horizontal stack, VStack stands for vertical stack. So core underscore features class type float x underscore scalar. So here the x is will be the features, all the features, core features and not core features. It's a scalar. Actually we talked about pre-processing our data, so that I have to normalize my data. So these functions that Scikit-learn provide to me that will make this a little bit easy. Okay, this is scaled x equal x scalar dot transform x. Okay, so here I normalize my data, and we took earlier, and we talked in previous sessions on how normalizing data is very important in our project. Okay, we have to define the labels. So this is the features. We will now define the labels. Okay, here we use again HStack for horizontal stack, so that will be horizontally, not vertically. Once then core score features. Heroes then Okay, not course. Underscore features. So here, okay, so far so good. I have made the X, which will have all the features of cars and not cars, and on the opposite side I have labels. So for any car I put 1, and for not car I put zeros. So there are 2 classes now. If it is car, the classifier will give me 1. If it doesn't detect car, so it will give me 0. Okay, from killer cross validation. Okay, train test split. Okay, so what I'm doing here is that I divide my training set into training set and testing set. So I have X and Y, I divide into training set and to testing set, so that when I finish training I test the classifier on the test set, so that I can know the accuracy or know the performance of my model. And as I said in the previous sessions, that performance of the model is very important, as I know if I succeed in my mission or no, I have failed. So we will see state okay. Underscore train underscore test y underscore train y underscore test. Okay, train test split. So this line will split my data into 4 variables: x test, x train, y train, y test. Okay, it takes the scale x y, and the test side size is the how from the total from my data, how many data I want in the test set. 20% of the data will be test set, and the rest will be used in the training set. Okay, so underscore state okay. So here I will begin. I define the model. I will begin to define my model for the training. So from scalar SVM grid underscore search data set datasets. Okay, everything is good. Okay. Parameters. I will use as we talked in the previous sessions. I will use SVM in this project, and the data is not very big. It is normal size data, so that SVM will perform well and will be fast and will give me the accuracy I need. Feel free to try any other classifier. You can get better model. Define the parameters of my classifier. First one is kernel. Just divide it into linear. Okay, C. Okay, 1, 5, 10, 2. Okay. So what I'm actually doing is that I will use grid search. Okay. So I have defined this parameter so that if you want to use grid search, and I will write it how to use it, it will be fine. Okay, this is all parameters. Now what we will do now is that we will show you something that I think it is interesting. So it is a little bit out of scope of our project, but I want to show this is very good thing to be. So okay, linear. Okay, SVM for linear SVC. Okay, linear SVC. Okay. Classifiers. Grid. Search. Grid. Search. Okay, we'll copy it from here. Grid search is CV. here we will put our classifiers. What I trying to do here is to use grid search. Grid search is something that is very interesting that we can use in our models, that it will find, it will look for the best combination between parameters, so that you can think of it. Grid search will try different parameters that I have defined here, and will find the best accuracy from the combination of different. For example, kernel equal linear and C equal 5 gives me the high accuracy. So grid search will find this accuracy and will return it to me. Actually, I don't know if this code will work or not. I haven't tried it. As I said, it is out of the scope. I will use the default. I will use the default parameters, so that we can delete all of this. I will delete all this. Okay. VC. Okay, so VC equal linear. Okay. Dot fit. So I will fit here my model. Train y underscore train. Okay, here I fit my model, and I want to calculate the accuracy. Okay, now I can print it using VC score x test y test x test x test y test. So this will give me the accuracy of my test set. I have used linear SVM in this project. You can run the code. I will show you how. But if you want to calculate the time of your model, of your training model, the time it takes to train it. As I mentioned before, I have library called time that help me to calculate the time. It access time now and can use it. How? Simply we can t equal time here, set time t2 equal by subtracting t. This is, I can here get, subtracting t2 from t, I will get the time the model take to be trained. Okay, before we start training our model, there is something very important we have to do. Pickle is library that helped me to save my model after I trained it, as I don't have to, when I want to use a project, to run it again. Okay, example, equal. Here I will put my parameters. K1 is VC. This is my classifier. Okay, this is all things I'm going to save. Okay, I want to save the so I wouldn't have to run it again from the scratch when I use the model. Orientation. This is the parameters I defined above here. Cells per cell. Or 5 cell. Here. Okay. Special size. Okay. Okay, we will save the model. Scroll out. Scroll open. Okay. Example. It is a little bit hard. Okay, when I make it close. No. Okay. So by doing this, I will save the model. So actually it is very easy to run the model. As we know, I can navigate through the my directory. Okay, so I will run this code. Okay, after you finish the training, you will find this file. Okay, this file is very important. It is the trained model that we have used. Okay, this is the last thing I want to tell. In this session we will continue to show and to we will test our classifier on test images, and we will see if the classifier work or not, and we will make it actually it is the most important thing that we will use the classifier on the a video and we'll see how it performs. Images is not a big deal, but we will see. Okay. This is the last session. We will finish our code and our project, and we will see the results of our classifier on the images and on the videos. In the previous sessions I have installed Jupyter Notebook. We will use it now. We will use it as Jupyter Notebook help me to visualize the images and the videos more easily than normal Python idle. So that I will simply open Anaconda and write Jupyter. I will it will open, so I can see I will make a new file, and I have prepared this notebook. I have copied these libraries here. I have loaded the data, copied the functions we wrote. All this we have done together. Okay, from here, as I said, the video, so I will use it in this session. Okay, let's begin our session. So the first thing I will do is to I will load the model I have saved in the last time. So scrolling, open, text, pickle. Okay, I have made a mistake. Example. So I have load the model. I will load the model that I have saved in this last session. Pickle dot load. Okay. I will now I will load the classifier example _2. Okay. X underscore scalar. You have to remember the sequence that you have wrote your picker file, so that nothing goes wrong. Hog orientation, it will be 3 pixel. Here I begin to load my parameters. Okay, using spatial size. Okay, we can run it very easily. So here I have made a function called convert color. It helped me to convert any image to the to what I want, to help me convert the image from RGB to anything I want. Here, why start, as I said, sliding window will start from this why start. We define the area. Earlier we have defined the function why start of the sliding window. From its parameters why start and why stop. So the sliding window will start from this why start and will stop in the why stop. So here why start is 350, so the sliding window will begin from the 350 y axis according to the image and will stop at the y stop. The rest of here is what we actually talking about, heat map. Okay, I want heat map. So heat map is help me to detect the car. For example, the sliding window will slide over and will scan the images several times, so it will detect the car several times. So heat map calculates these times. It actually work in different way, but we can think about it as it calculates the times that the classifier one car. For example, the sliding window can classify the one car several times, so heat map will count them, and by simply threshold we will make one simple sliding window. We will see. Okay, here I get hog features, image to search, so that the image from my start to I stop, I didn't identify any x-axis, so I want the whole x-axis, and it is reasonable because the x-axis can contain car in any direction, but y-axis I don't have to search on the sky, I want the region of the road only. Okay, so I have put some images on my directory, so can I test the classifier. So you can see here I have put these images. Okay, this second one, test 2, test 3. Okay, let's test these images. Okay, and run this. Okay, as I said, sliding window here, this is test 3. Okay, this is the images, the image I have now. I put my classifier on, so the classifier detect the car many times. The heat map count this, and by simply apply a simple threshold I will remove this by one sliding window. As we can see here, I put all this on one function so that I can call it and not write all this to classify one image. So here I made a threshold. This threshold take two parameters, the heat map that I made and the threshold. The main idea that we can think about, the sliding window here detects the car, we can say 10 times. So I can apply threshold that if you find 3 sliding windows in the same place, so it must be a car. So remove those 3 sliding windows by 1. And if you saw a sliding window only, one only, remove it. And this what happened. I made this threshold, and we can see when I run. Okay, when I made this threshold so that the car is detected. I don't want to go over the heat map and the sliding window. As I said, it is constant and we can use it as a black box. So here I detect the car. If I use the sliding window only, I will get this image. The heat map helped me to make this. Okay, let's try different image. So we can use test 4. Okay, so here the sliding window detects the car and the heat map. So I have to change it. That was 1. Okay, so it detects the car and it is a false positive or false negative that was detected. So if we want to detect the car with more accuracy, we can increase the threshold, and it is a parameter that can be tuned. So here, as you can see, I can try different. Let's say 2. Okay, it's a lot of. Okay, when we try it actually work and detects this car. So the last thing we can do is test. Okay, so here detect a lot of things by applying this threshold. As we said, you can see better results. So here it detects the car. Okay, so let's move on the video. So we will talk about the vehicle detection. So I will write it. Okay, we can delete this. Okay, okay. So firstly, we'll define vehicle detection. It is a new function, that take image. We'll take an image. Take an image. So we will make here the functions that will be used in the video. So I wanted to talk about the scale. The scale we are define here as we said, the sliding window scans the image many times. So if the sliding window found a car, it will make a rectangle. So by making a scale so that I can scale this rectangle into different size, and this will be very useful in our case, and we will first find the car, take the image and the scale. So I will scale with difference. I will copy this and I will scale with different values, so that if the sliding window miss a car, or if the sliding window miss a car or detect it with little bit what I want to say is that if it detect it wrong, or if the sliding window doesn't detect all the car, this scale will randomly help me to get to the car again. So I will put different scales. As I said, you can use this as a black box. These parameters you can tune as you want. So I will use okay. So as I said, the scale will scale this rectangle that are drawn. We can see here. You can see here. Okay. These different rectangles. Are caused by the sliding window. The heat map detect the footprint of this we get the right detection. Scale help me to scale the rectangle of the sliding window, so that it detects the car in better way. Okay, we'll name it 2 and name this 3. Okay, heat score map. Score map. So I will sum all of them to get the benefit of all the classification. And right, I will, if anything goes wrong, I will get it also, but all we can say is that it is parameter tuning. It is a kind of art to tune your parameters with a better way and with high efficiency. Heat equal. Here we will apply the threshold that we are talking about. Threshold. Okay. As I said, don't depend on my code. Go to the source. I write it to make you understand and to clarify the the project more, but the source is more important than what I write. So okay, here we will draw the image, and we will draw the boxes of the sliding window labeled. We will copy the image. Labels, and we will return. Sorry, we will return our drawing image. Okay, so far so good. So the last thing I will do is to process the video. So this library which we installed, movie API.editor, help me to process my video. Okay, video file, clip, okay, from Python. Sorry. Okay. Display, import HTML. Okay. Can say white. Can say white. Let's go output equal to. Here I will show you my video. This is a project video. I will test it on it. I will test my classifier on it. So it is a long video. I will not make all of it. So I will take only the name of this file. You have the flexibility and the freedom to use any other video. What you have to see the number of the frames per second. I think you can't do more than 25 frames per second. This is what I think. So this video is have some properties you have to check if you want this video. I will tell you the source now. Project video. Okay. Project video. No, I will write here the name of the output video that I want. So I will call it car detection. Okay. Here I will put use the video I have showed. Okay, video file. I'm sorry. Video file. Clip. So this is called project video. Okay, I have to mention style, sorry, mb4 to mb4. Okay. I can't process the whole video, it will take very long time, so I will subclip it. Subclip is a function that helps me to choose the time I want to process this video. So I will choose 45, 40 to 45. Okay, just 5 seconds. White, can make it 50. Okay, white, squash, clip, equal, clip, 1 dot 1 underscore image. Here we will use vehicle. We will use vehicle detection. Okay. And finally we'll write this. Score clip dot write score video file white output audio. I don't need any audio here. Okay, let's move on. Okay, gives me an error. Okay, I have to restart my notebook again, so I will save it, restart it from the beginning. Yes, I have increase this. It will give me an error. I forgot to put it in the libraries in the first when we talk, and we will and when we write it I forgot to include matplotlib by yplot as BLT. Okay, we will run the notebook. Okay. I will see this error and I will fix it. So when this error happened, I prefer that we restart the kernel. So I will restart my kernel. Okay, and I will restart. We'll refresh. Reload it. Okay. I will wait until the kernel be ready to start process our video. This star means that the code is running. It doesn't finish it. Okay, we'll wait until it finishes. Okay, the kernel is ready, so that the code is running now. Okay. I will pause the video until it finishes. Okay, it runs. Okay, version of this. Define core is not defined. Okay. Oh, I have error here that tell me histfence is not defined, so I can define it. So I forgot to define it. As I remember, it was 20, not 21. Okay. Got another error. X scalar is not defined. Okay. I got some errors. X scalar is not defined. The same errors. Okay, I have mentioned it before. X scalar is not defined. Okay, I will run this again. Give me the same error. Could be something wrong in the okay. I found the error. I wrote it scalar. Times e small. Okay. Okay. Work. Okay. So far so good. I hope it will process the video. Okay, it will give me an error. I'll fix it now. Okay. Tell me video foil clip object of 1 inch. Okay, it will be a small thing, I think. Okay. It's not defined. Video foil clip is not defined. Okay. Video foil. Returns some error. Give me the same error. Clip 1 image. Okay, I think I found the error. Okay, I didn't find anything. I don't know what is error. But when I checked this, I found that there is nothing called F1 called FL. So I modify it. Okay, this is another error. Draw label. Okay. Labeled. Okay. Wait, that is not defined. Okay. White out. Yes, it is not defined. I hope it is process the video. Okay, it began to process the video now. will take a while. In this time I will show you how to get the video if you want it. Okay. Okay. Right car. Detection. Okay, this GitHub contains a video and some images if you want of this. Contains a video that I used. It is called Project Video 10 before. You can download it very easily. So I will pause the video, and when it is done, we will see it together. Okay, the video have been finished. Okay, it is here. Code detection. We'll open it now. See the results. Okay, it is work. As we see here, it classifies cars in the other side. Okay, so finally I want to say that this project is based on vehicle detection project from self-driving car nano degree from Udacity. I want to say that this is the end. This model can be modified with better performance. We can change the parameters we have used in these functions. As we increase the number of anything, it will be better. So if we increase the hog orientation, the cell per block, the spatial size, haste bins, anything will increase the accuracy, but also take care if the model overfit. The project may not run on your laptop if you have an old one. So if you found any problem, you can decrease these parameters, or you can decrease the hog features so that it run on your machine, whatever you use. I hope this tutorial was helpful, and see you soon.